Hey geometries, how about a little wrap up of yesterday's lesson? So we'll go ahead and make sure that you understand each of these things that we may or may not have gotten through when we were in class together. So let's do these together. Think about each segment in the diagram as part of a line. Which of the line appears to fit the description? So when we're talking about parallel to AG, so I'm going to go ahead and get my ruler to make sure we can see AG. So here is line AG. And if I want to find something that's parallel to it, see, I should have skipped my ruler. If I want to find something that's parallel to it and contains C, we're going to have to think about this being parallel and sliding this down and containing C. So that looks like that's going to be here. It's going to be line CI. Perpendicular to AG and containing B. Let's go with this line here. You don't know this yet, but this is a hexagonal prism. And by definition, a prism has rectangular sides. So because I know this is a right angle, I know that that's going to be perpendicular. So when we're talking about perpendicular to AG and containing B, that's going to be line AB. Skew to AG and containing C. So C is going to be this line, or this point right here is where C is. So if I'm going to talk about skew, I'm going to talk about a line that contains this and is never going to intersect with AG. So it can't be anything parallel to it. It can't be anything that's going to intersect it. So I can talk about, there's a couple different answers here. I know that line CD is never going to intersect AG. If you wanted to say CB, that would be another possibility. You can't say CI, but if you want to get creative and say CE, CF, CJ, you can do any ones of those as long as it contains C and it's not parallel and doesn't intersect with AG, which would just be CA or CG. All right, the plane that contains C and appears to be parallel to plane AFL. Let's see where AFL is. So AFL is going to be this side of our hexagon here. So if I slide that down, we're looking at this underside here. So that plane is going to be CDJ, plane CDJ. Now if you wanted to name it CIJ, you could. You could also name it CJD. I'm sure there's a couple others too. But it's just easiest to restrict your naming planes to 3 letters. All right, let's talk about this cube, and the line we care about this time is going to be line BC. So we'll go ahead and draw that in our pink. Let that stand out. There's line BC. All of the lines that are parallel to BC are going to be all of these other vertical lines in our diagram. So we can go ahead and talk about line AD. Here it is. We can talk about line EH. We can talk about line FG. 1, 2, 3. Each of those lines are going to be parallel. A pair of parallel planes, and you have 4 different choices. Let's see if that's 4. 1 on top, 3 different choices. Your top, and these sides, if you want. So we'll go ahead and choose the top and bottom of our box. So we'll talk about plane AEF and plane, that's our top, DHG. And you know, it's good to make sure you're talking about corresponding points. We're going to talk about this in the future with triangles. But if you're naming this AEF, the correct thing to do is maintain that pattern in how you named it. 2 lines that are skewed to AE. All right, so when we look here, we want to find lines that are in a different plane and not intersecting or parallel. So here's AE. So BE is out, EH is out, AD is out, DH is out, and CG is out. So I want you to think about all those ones that we can't do. We'll go through them again. This is parallel. This one's parallel. This one's parallel. This one intersects, and this one intersects. This one intersects, and this one intersects. So you can see we don't have any of these options here. When you talk about all the lines that we have left as a choice are going to be line FG. We're going to talk about line DC here. And we'll go ahead and talk about line HG. So DC we didn't X out. HG we didn't X out. We didn't X out FG, but all the other ones we did. That's a great question. You might want to be ready to see that one again. Okay, identify each pairs of angles in the diagram. Okay, so here we go again, looking at each of these different kinds. Name the two lines in the transversal that form each pair. Wow, look at this. So when we're talking about all the different pairs of each diagram, let's go ahead and limit ourselves for the sake of time and make sure that you understand about corresponding angles. Alternate interior, same side interior, and alternate interior. So we'll go ahead and we'll look at just a couple of these real quick. So if I talk about 7 and 5, right? So if line B is my transversal, right? So if I have B as my transversal, I'm going to end up with 7, angle 7, and angle 5 are going to be corresponding for sure. All right, now let's go find some alternating interior angles. So if I have these two lines, let's go ahead and talk about if line A is my transversal. And I'm talking about these two lines for B and C. If line A is my transversal, then alternate interior angles are going to be angles 1 and angle 3. Same side interior angles, also called consecutive angles. Let's stick with line, let's see, let's find some same side interior angles. So 3 plus 4 and 5 would be 1. We're going to go with line D as my transversal. So if line D is my transversal, then angle 7 and angle 8 will be same side interior. All right, let's talk about alternating exterior angles. Let's try to get line 6 into the picture here. We're going to go back to line B being my transversal, and we'll talk about angle 7 and angle 6, or alternating exterior angles. All right, how many pairs of lines and transversals are shown? So what's interesting is each of these lines have the ability to also be a transversal. So I can have, how many lines and pairs of transversals are shown? 3 pairs. Name each pair in a transversal. Okay, so if B is our transversal, A and C are the lines for B being the transversal. All right. If A is the transversal, B and C are the lines for A, and if C is the transversal, A and B are the lines for C. So we can talk about C being the transversal that connects A and B. We can talk about A being the transversal that connects B and C. And then, of course, B can be the transversal. So by definition, a transversal is any line that forms intersecting line or angles when it intersects with two other lines. All right. So the last part, the last question that was on your slides to talk about next is going to be this one. It seems simple after the other ones we've done, doesn't it? Okay, which line fits? Let's see, parallel to PQ. And I think we did this in class, but it's okay to go over it again. Parallel to PQ and contains S. We're going to call that ST. Perpendicular to PQ and contains S is going to be PS. Skew to PQ and contains S, that's going to be SU. And the plane appears to be parallel to PQR. Slide that over like we did in class, and that's going to be plane SUT. So, all right, so you have that to complete your slides, which I asked you to finish for homework. Awesome. Keep going.